Homework 5 here is mainly around the structure of the atom and the periodic table and how the two link together. So if you're struggling, well worthwhile going back to the book and having a look at those pages about these topics, because it might well help quite a bit. Either way, I'll try and help with some of the questions. Obviously, I'm not going to answer them because that's your job, because it's your homework. First question here. An atom of zinc has an atomic number of 30 and a mass number of 65. How many protons, neutrons and electrons are present? Well, I'm not going to do zinc. I'll do sodium here. So let's do sodium. Sodium's got a mass number of 23, so we'd write that at the top like that. And an atomic number of 11. The bottom number here tells us the number of protons in the nucleus. That number is unique for every element. So sodium, if I was doing this for sodium, a particle of sodium, I'd say proton number was 11. Okay, you're doing it for zinc, so the answer is not 11. Okay, now, all atoms of the same element are electrically neutral, so protons are positively charged. So sodium has 11 protons, so it's got 11 positive charges in the nucleus. Now, because it's neutral, it must therefore have 11 negative charges. The particle that is negatively charged is the electron, therefore the number of protons equals the number of electrons in elements. When elements form compounds, they can gain or lose electrons, so that's not true for atoms in compounds, just atoms and elements only. Now, the top number is called the mass number. Now, protons have a mass of 1, and neutrons have a mass of 1, and electrons are virtually weightless. Okay? So that therefore means there is a combined total of 23 protons and neutrons. Not 23 of both, that would be 46 combined. 23 of both of them together. Okay, now we need a number of neutrons. We have the number of protons, it's 11, the bottom number tells that. So of that combination, 23 protons and neutrons, 11 are protons. Therefore, if we subtract the 11 from 23, we get 12 as the answer. Therefore, 12 of this combination are neutrons. 11 and 12 together make that 23. So 23 minus 11 equals 12. So our next question, which period is zinc in on the periodic table? Well, I've got a copy of the periodic table here. Now, the periodic table is arranged in groups and periods. Now, groups go down, that's group 1. That's group 2, this is transition metals in the middle. There's group 3, group 4, 5, 6, 7, and group 0. Okay, they're groups. Groups go down. Now, this question asks about periods. Periods go across. So period 1 is this top row here. Everybody forgets period 1 when counting what period an element is in. So that's period 1. Row 2 is period 2, row 3 is period 3, row 4 is period 4. So you simply have to find zinc and tell me what row it's in, what period it's in. Well, we did sodium a moment ago, so here's sodium. Okay, now if I ask that question in class, 90% of people are going to put their hand up and tell me that is in period 2, because they go period 1, period 2, and of course they are wrong. And they're wrong because they have forgotten the first period. The first period is here, hydrogen, helium. Period 1, period 2, period 3. Sodium is in period 3. Don't forget the first period. Right, you can do that one there for zinc. How many electron shells would we expect zinc to have? Okay, well, the period number tells us the number of electron shells. So a moment ago we looked at sodium. Remember, I'm not doing your homework for you. You need to work out where zinc is. We looked at sodium. We said sodium was in period 3. Period 1, period 2, period 3, period 3. Okay, that tells us it has 3 electron shells. Okay, the period number is equal to the number of electron shells. Next question. Zinc exists as isotopes. What is an isotope? Okay, so if we look at maybe another element, let's look at hydrogen. That's the easiest one of all, I suppose. Hydrogen is made, or can be made, of 3 different isotopes. And these are atoms of the same element. There's 3 elements of hydrogen there. 1, 2, and 3. These are atoms of the same element. They're atoms of the same element because they have the same number of protons. That number of protons is absolutely unique for atoms of the same element. So an isotope is 2 or more atoms of the same element with the same number of protons. But looking at these numbers here, these mass and atomic numbers, what's different? Well, from the atomic number is 1, they've got the same number of protons and electrons, so that's the same. But the mass number is different, so what's different therefore? It's the number of neutrons. So isotopes are when you have two or more elements of the, two more atoms of the same element, so therefore the same number of protons but a different number of neutrons. Now, it's possible to have a sample of naturally occurring element. Copper is the example in this question. I'm going to talk about lithium now, I think, to help you out. Lithium, okay, can exist as lithium 7, an atomic number of 3, and lithium 6 with an atomic number of 3. Okay, now, if you look at a sample of naturally occurring lithium, it's made of 10% lithium 6 and 90% lithium 7. And now the question is, what's the relative atomic mass of that sample? Well, to do that, we need to do a calculation. That's what we have to do in this question here. It says copper exists as isotopes. A sample of copper contains 70% of copper 63. When it says dash 63, it doesn't mean minus 63. That's another way of writing the mass number. So, that's lithium 7, so writing it like the question, lithium dash 7. Okay, that's the mass number. 70% of copper 63, 30% of copper 65, uses information to calculate relative atomic mass of copper. So we need this formula. Percentage times mass, and we need to do that in brackets for every isotope. Okay, now we've got 2 isotopes here, so we're going to do that twice. If we had 3 isotopes, we'll do this 3 times. If we had 4 isotopes, we'll do it 4 times. You get the idea? So it's percentage times mass plus percentage times mass, and then you divide all that by 100. Write that out, you get 1 mark. And I'm going to do it for this, you're going to do it for that. So the mass number of this is 7. Okay, so 7 is the mass number. 90% 7, so 90% 7. Okay, plus mass number 6 and 10%. So 10% times 6 divided by 100. Okay, working that out, 9 7s are 63, so that's going to be 630. Plus 10 6s are 60, that's going to be 60 divided by 100, so that's going to be 690 divided by 100, or in other words, 6.9. Now that's the relative atomic mass, so there is no unit at the end of it. You need to do that for that question. Mendeleev. Mendeleev is the father of the periodic table. Now, how did he arrange his periodic table? Okay, well, Mendeleev arranged his periodic table in order of atomic mass. Okay, so as we read this by a book, like a book, we start from left and go to the right and then carry on down to the next row and the next row. You'll notice the mass goes up and up and up and up and up as we go down this periodic table. Mendeleev arranged his periodic table by order of atomic mass. Having said that, it's not one giant long line, is it? It's broken into groups. So he arranged the elements in groups based on the properties of the elements and the properties of the compounds of the elements. For example, lithium, sodium, potassium, all very reactive metals. That's the properties of the elements. But if you react all those with water, you get lithium hydroxide, sodium hydroxide, potassium hydroxide. They are compounds, lithium hydroxide, sodium hydroxide, potassium hydroxide. Now, all those compounds are alkalis. So that's the properties of the compounds of the elements. But he wasn't afraid to leave gaps for yet to be discovered elements. Okay, so, and he then made predictions. So he arranged them in groups, but he wasn't afraid to leave gaps, and he also wasn't afraid to reverse his order if he felt the elements would be better suited in a different group. For example, here, antimony, 122 mass number. Tellurium, 128. That follows. That's heavier. Iodine, 127. That's lighter. So Mendeleev, to start with, had these the other way around, but then he realised that iodine matched bromine, chlorine, and fluorine, so he reversed his order. Okay, so that's how he arranged his elements. You can write that down. What group of the table is carbon in? Well, find carbon. Okay, that's simple. Yes, find carbon. What period of the table is chlorine in? That's just a question about groups and periods. Again, we've covered that already. An element is in period 3 and group 4. How many outer electrons and shells does it have? Okay, was the outer electrons are told to us by the group number. So everything in group 7 has got 7 electrons on its outer shell. Everything in group 3 has got 3 electrons on its outer shell. The period number tells us the number of shells. So period 1 has got one shell. So if we were to look at this element here, magnesium, it's in group 2, so it's got 2 electrons on its outer shell, and it's in period 3, so it's got 3 shells. So that would be period 3, group 2, 3 shells, 2 electrons on the outer shell. Have a go at that. And then we've got a balanced equation. Now, we've done lots of balanced equations recently, so hopefully you can do that without too much help. But it tells us one of the stages in production of sulfuric acid is reacting sulfur dioxide with oxygen to make sulfur trioxide. If you can't remember the formula of sulfuric acid, go back to homework 1. It's there and you need to learn it. Okay, oxygen is a diatomic molecule, so get that right. And sulfur trioxide, that's the other formula. Get the formulas right in the equation, then balance them. Which subatomic particle is unique to every element? Well, I'll give you a clue. If you look at the periodic table, even if you can't remember it, if you look at the periodic table at the back of your book, there's a key there on the periodic table. Okay? And the bottom number tells us, gives us the element's identity, and there's a little bracket after atomic number. Even if you can't see it in the video there, go to the back of your book and look at that key. Okay, homework done.